close to the end of the year, and there's only so much we can do. So.
Are we doing? How many more chapters are we doing before the exams?
We are going to work through section 6 here, and then we're going to do a little bit of just so you guys.
Like not in the book.
It will be in the book, yeah. I think it's like chapter.
This is like our last like official.
Yeah, algebra 2, not trigonometry.
I know, but somebody will take math after this, and there's always trig on it.
We can not it.
There's a lot of trigonometry stuff. Some people always have trigonometry.
I got 10 credits.
I don't have math. 4.
Enough.
Geometry algebra.
Okay, math. All right, so we're talking about rational equations. So remember, rational just means that we have a fraction and we have a variable somewhere in that fraction. That makes it rational. Okay? So rational equations with an equal sign, and we're going to be solving for the variable rather than just simplifying. So we're going to use the same ideas as what we've done before, when we were adding and subtracting and multiplying and dividing those rational expressions, but now we're just throwing in an equal sign and solving. Okay, so the easiest way to do this is to eliminate the fractions by multiplying each side by the least common denominator. That way, once we multiply by the least common denominator, the denominators are gone, and then it's a lot easier to solve for x, and you don't have to worry about fractions. Okay, so on part A, it asks us to solve. Let's check your solution. So I would first find least common denominator. So that means we have to find the factors of each thing. So what are the factors of x plus 3? Just x plus 3, right? Okay, what are the factors of 6? 2 and 3. What are the factors of 18? 3, 2?
That's 2 times 3, right?
Yes. Okay, so remember with least common denominators, we want to pull out each thing that appears the most amount of times, right? Well, x plus 3 only appears once, so we want him in there. 2 appears here and here, but it only appears once. And 3 appears here and here, but it appears twice, so we want it twice over here. Everybody remember doing this? Coming back, I hope? Yes. All right, so what's 3 times 3 times 2? So we're really taking in 18 times x plus 3 is our least common denominator. So that is what we're taking times each fraction. Not just the one on the left, but the one on the right as well. Okay? So I would write it as 4 over x plus 3. Okay? And if I'm going to take this and make it look like the least common denominator, what do I have to take it times? 18. So I'm going to say times 18 times 18. Alright, we've got 5 over 6. What do I have to take this guy times so it's the least common denominator? 3 times 3x plus 3. Okay, and we've got the last one. What do I have to take in times? Okay, everybody follow so far? Yes? Alright. Okay, so now what I would do is I would look and see if we can cross cancel anything or like simplify the fractions, which sorry, I shouldn't say simplify. I mean put together. So what is 4 times 18? 72? You sure? Yep. Yes. Okay. And then I would say 5 times 3, 15, x, and then 15 times 3 gets us, what would that be?
Don't do it.
45.
Sorry.
Don't you have to distribute first before you multiply, or you multiply by 5 times 3?
I would get the same thing as you did either one.
But then you got 3x plus 9, and then you 5 times 14.
9 times 5. Okay, so 5. So then we've got over 18 x plus 3 equals 23x x plus 3 times 23. 69. Say that right, go ahead. Go ahead. Okay.
Man, this is hard.
It's the same stuff as what you did before in sections 1 and 2.
But I got a 10%.
Alright, so now let's simplify. What's 72 plus 45? Can we put those together?
113.
Why did you get 23x? Because I distributed. Oh,
We just take the top of equal each
well, can we? Is that true? Yeah, because if I'm dividing by the same number on each side, they can just go away. So we don't really have to worry about the denominator at all. Because, like if I had 5 over 7 equals x over 7, if I'm dividing by the same thing, x has to be 5, because that's the only way that they're equal, right? So same thing happens here. If the denominators are the same, which they are, then I can just say the top has to be the same. Alright, so how would we solve for x?
This is when it's 60.
Okay, so if we subtract, what do we got? And then do the 15 over, so, help me out.
equals 6.
X equals 6?
You want to add?
Thank you, Greg.
So we have to
Alright, so then, we always have to check. Always have to check. Taylor, Lindsay, eyes up here, please. Okay, because sometimes when you are multiplying by the least common denominator, even if you do everything right, sometimes you will come up with an extraneous solution. Remember, that's when you do all the steps right, but it doesn't work when you plug it back in. So always check your answers. These are really easy to check. So all you can do is plug it back in over the top. So I would think, okay, x is 6. What's 6 plus 3? So I have 4 9s plus 5 over 6. Let's see if that's really 23 over 18.
Yeah.
Is it? Yeah. Because remember when we're adding fractions, you have to make sure the denominators are the same again. So I would say you could plug it into your calculator or think times 2 times 2 gets 18 times 3 times 3. So that'd be 8 plus 15 really is 23. So you do it. Alright, any questions on this? Because that was over 18.
Is this basically the same thing?
Yeah, it's basically the same thing as what we did before, adding, subtracting, multiplying, dividing these rational things, but instead of just simplifying, we're actually solving. Okay?
What are we going to have
Not this week, but next week. Alright, do you want to do this one, or do you want to move on to something a little bit different? This is exactly like what we did. Alright, again, just like what I said, you have to make sure you check because sometimes you get extraneous solutions. Alright, with these types, you're going to do exactly the same thing. Factor at the bottom, make sure you find the least common denominator. So if I'm looking at this first denominator, what are its factors? Just x plus 5. Okay, can I factor this guy in the middle? Okay, and the guy on the end is just x plus 3. So what's our least common denominator? Which makes it nice because that means that our middle term isn't going to change at all. Just set it on the stack here. Good? Same and alright, so with our first fraction, what do we have to multiply by so that we get our least common denominator? Yep, x plus 3. So I have 2x times x plus 3 over x plus 5, x plus 3. How about this middle one? Right, we don't have to do anything. I would factor the top though, just to make things Well, no, let's just leave it. Okay, and what it's equal to, what do we do? So 3 times x plus 5. All right.
So wait, how
How did we want now?
you combine those two together, right?
Yes. Oh. All right, so we're going to have the same denominator, so we can actually subtract these. So I would distribute through, so I'm going to have 2x squared plus 6x. And then we are subtracting this whole thing. Make sure you put them in parentheses because we want to subtract everything.
Because you get to cross out the bottom.
Because we have to cross out the bottom.
Wait, what? No, we can cross out.
Oh, yes, because they're the same. We could just work with the top, yes. Yep, because the denominators are the same now. So all we're worried about is the top. So we've got 2x squared plus 6x minus x squared plus x plus 10, distribute the negative through, equals 3x plus 50. Yeah, distribute the negative, so we need to subtract this whole thing over here. So this is a negative, positive, positive. Alright, so then I would just combine like terms over here on the left side. So x squared is combined, we just get x squared. 6x plus x is a 7x. 10 is just 10. Then what do we do?
Wait, why did you change those to pluses?
Because I'm subtracting this whole thing. Because I want to distribute the negative. Alright, now what?
Quadratic equation.
Quadratic equation. Ooh, ignore that.
You move over the 3x and 15.
Yeah, so before we can get to quadratic, it has to equal 0. Yep, so if I subtract the 3,
This is pretty easy to factor too.
it would factor.
A lot easier quadratic equations.
I like quadratic. That's just
Minus 5. Because then it's x minus 1 and x plus 5.
I need the box.
you don't have to do the box because there's no coefficient.
What is the box? I forgot what the box was.
The box has to do with if you have a coefficient here to the a times c on the factors of ac. Yeah, I think in this case it's just it's there are no coefficients. Let's see, 5 and 1
Plus 5 minus 1.
minus 1. Okay, so if I were to solve, x equals negative 5 and x equals
Yeah, negative 5 doesn't work because in the first fraction you don't define fraction.
right. Always check your answers for extraneous. Yeah, up here, if I put in negative 5 plus 5 is 0. Why does that not work?
It's undefined.
It's undefined. So let's move extraneous. Is it?
Would it be all negatives?
No, not all negatives.
Oh.
No.
Because I mean, if you have a negative 5 and x plus 3, that works.
How do you know for one works?
No, like if you put the negative 5 into the x and x plus 3, that would work.
Oh, yeah, this works. Right. So this one is not. So we plug it in here.
Where
Where do you plug it in?
It's in the book, right?
Well, you would plug it into 3x, but the only one we're worried about is this one, since it makes it undefined.
I can actually do this now.
All right, are you guys want to do this process?
No.
Sure?
Oh, 16 pots.